So last time we talked about the limit or the range of numbers, right? Especially integer numbers and floating point numbers. And I said that this code can be easily generated by the ChatGPT. You don't have to remember what these functions means or what do this means, right? And one thing I want to mention is this kind of sizes, they can be defined by your compilers. They don't have to run this code to know it. So especially when you are trying to do something like the pre-compiling, yeah, but at least for now, you don't have to remember what this one means. But this one means this size is defined by the compilers, not be the runtime during runtime. All right. So there are many other types. I would list a few here. So first type is called Boolean. Boolean types are just true or false, right? In Chinese, 真假, true, false. True, false are very important when you are doing the branches, if, else, control, flow, right? These kind of things are very important if you know the Boolean type. And true, in your machine, they stored as 1. And false, they store in machine as 0. But if you want to cast, for example, if you want to assign some value 0 to Boolean value, it's also valid. You could assign 0 to a Boolean value, right? How can we define a Boolean value? Bool a equals to 0. You could do that, no problem. This is how we define a variable, right? The type is Boolean, the value is 0. But indeed, your machine will sometimes, if you can consider in that way, 0 means a false, right? It is assigning false to a Boolean value. Or you can assign 1 to a Boolean value. It's also fine. So that's we call Boolean values. And we will talk more about Boolean values when we talk about control flow, maybe next week. And other type, first one is called void. Void, it means nothing, empty, right? It's very similar to none in Python. So it's when we talk about function calls, function return values, we will see this kind of types. And non-pointers, these are a little bit harder. When we talk about pointers, we will cover that. But at least for now, you just know they exist. All right. Today, we will spend most of the time talk about the characters. So characters are 1 byte in size, right? A, B, C, D, they are all characters. And we also have some special characters. First one is a tab key, right? It's the tab key in your keyboard. And a \n is a new line. So how do they store in computers? It's basically look up this table, this ASCII table. Let's make it larger, right? Every symbol has a number for it. For uppercase A, capital A, the number is decimal 65, right? If it's in hex or base 16, it's 41. You don't have to know it. The decimal number is 65. For capitalized A, the value is 97 for lowercase a, right? These are the strings stored in your computer. So what does it mean? For instance, if your machine is trying to store A, B, C in your memory, right? In your memory, you have a memory. So the first number it stored is 65. Next number is 98. Next number is 99. We said in your machine, everything is binary, right? Everything is number. So if you look at here, it stores 65. Your machine knows it's a capitalized A. If it's 98, it knows it's a lowercase b. If it's 99, it knows it's lowercase c. All right, so this is how everything is stored in machine. They are in numbers. So one of the questions in OJ system, it might not be suitable for you to do it right now. It's converting from uppercase to lowercase, right? But this one is more complex because it has 5 symbols. So you need maybe a for loop. We will cover that in next lectures. But at least you can convert one symbol, right? How can we convert from capitalized A to lowercase a? Plus 32. Yes, that's correct. Because we know lowercase a is 65. No, uppercase a is 65, right? Lowercase a is 97. So what we can do is, so today's class, I want to show you using my Xcode. This is Xcode in my MacBook. This is IDE, exactly the same as your Visual Studio. Let me show you how to define a variable, right? A variable, which is a character, let's call it a capitalized A, right? And we can assign capitalized A to it. This is how we define a variable named capt A. Cap A is a name. It's just a name. The type is a character. The value is uppercase A, right? And we know this value is 65 stored in machine. So what we can do is we can create another variable called lowercase a, and the type is a character. And what we can do is we can cap A plus 32, right? This is what we can do. We can add a character by an integer. We can add some integer to a character because we know in the lower machine, these guys are nothing but some numbers. So this is something you can do. Let me include the IO stream and output this lowercase a. Right. This is the simple program. Let's run it. Right. This is the output lowercase a. We simply adding the uppercase a by 32, and it will output lowercase a. This is because of the ASCII table, right? This is the table people have defined. The whole world agreed on this. They know what's the number represent in character and what this character represent in numbers. So people could communicate. Yes, question. No, you don't have to memorize that. So if I don't memorize, if I cannot remember it, how can I know the number 32, right? Yeah, you can compute this 32. So yeah, right. So understand my question? If I cannot remember the whole table, right? How can I know this value is 32, right? This 32, you can know 32 because you know this table, right? You know this table, 97 means lowercase a, and 65 means uppercase a. Then you can do 32, right? Divide 97 by 65, you know 32. So the answer is using your program to get 32. How can you get 32? Let me see. If I define something called a distance, right? Distance between lowercase a and capital A is 32. Then I can do put a distance here, right? I can do something like this. I define some variable which is integer called a distance. This is 32, and I'm using this number to do computing, converting from uppercase to lowercase, right? The question is, how can we get 32, right? What we can do is very simple. Right? If I don't know what A is in your ASCII code, I just say minus lowercase a by uppercase A, right? Then you can get 32. So that's the way you can get the difference. So even if your input is no longer capital, let's make it capital K, right? So uppercase, lowercase, because the difference between lower k and the upper k are exactly the same as lower a and the cap A. So you should get the lowercase k when you run this program. When you build it, run it, you can get the lowercase k, right? So that's how you get the converting from uppercase to lowercase. Similarly, when you want to convert lowercase to uppercase, you just minus this distance, then it will be done, right? All right. So that's the ASCII code. And if you don't know it, you just Google it. Google for ASCII table, right? This is ASCII table, and you should be able to find it. So about the special character, we said \n represents a new line, right? \t represents a tab. So I got an email asking me what, right? We can say hello \n. So people ask me, how can we output a backslash, right? It's actually not correct. If you want to output this one, right? Does that, what do you mean? Using double quote for a backslash, yeah, you will see some errors here, error message. And if you run it, build failed because it's compile error. So whenever C++ see a backslash, it will include the next symbol with it. So it will make the whole thing as one character. So it says you haven't finished this double quote because this double quote becomes a print message. What you can do is you put a quote here. So it will print a quote here. It will print a quote here. So whenever you put a backslash, it's called escape. It will print the next symbol in it, right? Even though this symbol is, if you think this symbol is a special one, right? It represents the beginning and end of a string, right? If you think about it. So if you want to output a backslash, you put a backslash here. You put a double backslash, it means one backslash. Okay, this is how you print the backslash. If you can see here, it will output only one backslash. So there are many special characters. If you can think of it, is \n, new line, right? It automatically do that. So \t, right? What we can also do is \\. If you want to print in your string, you can do \quote, right? If you want to output a quote. If you don't write it this way, you cannot output a quote, right? How can I output a quote? We do that. You put a quote here, you can output a quote. If you want to output a backslash, you put a backslash here. So it's called escape. You are not using the special idea of this quote, right? The special meaning of the quote is the beginning and end of a string. If you just want to print this quote, you need a backslash. So that's the usage of a backslash. You need to learn more about that if you Google that. So let me erase here, just to mention something about it so that you guys don't get confused. The most commonly used one is \n, all right? Creating a new line. Whenever you end, you create a new line. So this \n and std end line are exactly the same, all right? So if you're writing this way, you are creating two new lines. These two are exactly the same. You could choose either one. This is the special character. So strings. So we talk about the characters, right? Characters, then strings, they'll be slightly different. This is a character, single quote. This is a string, double quote. So string can be many characters, right? You could write as long as you like. String could be many characters long, and each element of a string is a character. All right, a character, just one symbol, a string, many symbols. Any of them is just one of the characters. So that's a string. So in the old Cs, in the C language, we don't have string defined. So in the old days, people define string, call them character arrays. So if you see C code, they're doing something like this, and they give it a name. For example, my name is string, and they can put a blah 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 to it. This is old C way, right? But in C++, what we do is include a string library and call it a std string. Right. So this is the way to define a string variable in C++. Double quote versus single quote, right? These are different. One is character, one is string. And we will cover strings in maybe in 6 or 7 weeks later. So that's the string, because there are many of the complex functionalities inside the string. But at least for now, let's just assume we could directly use it, right? All right, these are strings. And if you want to read more, these are just basically what we called C++. String is a sequence of characters, and you use the header, and the strings are enclosed by quote or double quote, and we will cover more right later. But at least for now, we will use it now. So I have to introduce a little bit. So variables, we already touched upon that. A variable is used to store some information, and as you can see here, we use a cap. This is a variable, right? This is a variable. str, this guy is a variable. Distance is a variable, right? Every variable has a type. First, the cap has a character type. Yeah, char. str has a string type. And distance has an integer type. And in the future, when we define classes is also type. And you are basically defining your own type for a variable. But as if for now, we are just using some standard types. In the future, you will define your own type. So that's the variable, right? We have a type. That's the most important part in C++, which is different from Python. And we say the names should be clear to others. The names are very important. Like I said, here I give it a name called distance, right? I'm not calling it K, right? If I call it K, it can also work, right? As long as I change this one to K. The code can still run, but the question is the readability. When other people saw your code, what is K, right? So even here, I use the cap. If I can, what I can do is I can do something like this, right? Right. What I can do is doing things like this. I can define a char C. I can define a string S. I can define int K. I can define a char L, right? If your friend write code like this, don't collaborate with them. You will never be able to understand what they are writing, right? That code might run, but it's very hard to read. So give every variable some meaningful names. And we say we would prefer some names using camel case. That's only my suggestion, like the student name, right? Because you are using one variable called student name. So we just make the second word capitalized, like this one, school address, capitalize the second one. The first character could be lowercase. That's typically what we do in C++. Another way to write a variable is like this. So we could say student name, right? This is one way to define a variable. Another way people typically do is like this. Right. This is all of the variables are in lowercase, but separated by underscore. So that's what people would like to do, because you cannot use the minus sign, right? Minus sign means minus. The only thing you can use is underscore. These are typically people writing in Python, they prefer this way. I would allow you to do both ways as long as you follow the same style, right? You could use this because you are already familiar with Python. If in that case, you can use one style for both classes. This is the way you can write. All right, or you can write the first one because the underscore are far away in your keyboard. So this way might be easier. But anyway, as long as your naming are good, that will be fine. I don't care about any styles. So you cannot use the reserved words, right? What are the reserved words? Can you define a name called int? You cannot, right? You want to define a variable called int. I'm sorry, they will complain. It has the predefined meaning for it. So these are called keywords, right? These are called keywords. Other than keywords, you could easily define any name, right? STD, can STD work? Yeah, maybe STD can work. Let's see. Yeah, STD can work, right? STD can still work. So any name that's not reserved by C++, you could use it, but try not to use STD because we know STD is a namespace. Yeah. Anyway, try to come up with your name that's meaningful, not conflict with the existing ones, and try to preserve a single style. All right, that's the variable name. So C++ is a strongly typed language. We mean strongly typed is whenever you have a variable, it should be associated with a type. So in C++, like this one, whenever you define a variable, name becomes a character, you cannot reassign name to be something like the, for instance, string, right? You cannot do that because it is complaining assigning to character from some other type anyway. So you cannot change it. But in Python, you can do that. In Python, they don't have to specify the type, right? What they can do is, in first line, they assign a character to it. Next line, assign a string to it. Next line, assign an object to it. That's all valid in Python. But in C++, it's different. It is strongly typed. Whenever you declare a variable, whenever you define a variable, it has to have specific type to it. And the reason C++ do that is the compiler is trying to catch as many errors as possible during compile time instead of during runtime, right? When you run it, if the code is wrong, then you will fail this program or your machine will fail. So they are trying to escape from this kind of situations. They are trying to detect as many errors as possible. So it's strongly typed. It will check your conversions or your, in the future, we will talk about conversions, but as is for now, they have to be the same type, all right? And they need to be specified when declaring a new variable. And whenever you declare a variable type, it will allocate a specific location for you, right? If it's a character, it will allocate 8 bits for you. If it's integer, it will allocate 4 bytes or 32 bits for you. So the space is limited. The space is fixed. So you cannot change during runtime. That's also making the program runs faster, right? It knows exactly where the elements are. All right, so we have 2 ways to, we say 2 names you have to memorize. First one is called a declare. We say declare, we only say, okay, this variable, please define this variable for us. We didn't specify where what's the value it should be, right? This one is called initialization. When you declare it, you also initialize it. But if you only declare it, you will never know what is the value of it, right? So that's how it works. Remember we said we have this is our memory chunk, right? Whenever you say, okay, I need a variable, which is, the name is A and which is the size integer, it will allocate 32 bits of memory space. This is our memory space for you. And it tells you, okay, this one represents an A, right? That's int a does. It didn't initialize the values in here. So whatever exists in here in your memory, this one could be some random bits. So any number in here will be your value of a. So if you don't initialize it, you will get some very weird numbers. Let me show you the example. Here, let's say, wait a minute. Let's put an int a here, all right? Then let's output a. Let me run it. If you didn't specify initially, it will give you some weird number. Second time you run it, another weird number. That is because you didn't initialize it. It just allocated some space in memory for you, and that space may exist some values in it. So you have to initialize it so that this number is fixed. This is called initialization. This is called declare. You only declare the space. It didn't declare the existing or initial values. So that's how we declare some variables. We can declare integer, declare floating point, declare strings, and we could also declare multiple values at the same time, as long as they belong to the same type. Right? We are defining 3 integer variables here. These 3 variables, they are independent, and you can use them, or you can define them in this way, right? Some of them initialize them. I initialize as 0, K initialize as 1, but J, you didn't specify the initial values. So it could be any random number. So this one is the values, all right? And I put a note here, but you don't have to know it because we haven't defined what we mean by global values, global variables. So I just mentioned a little bit here. When we talk about the lifetime, we will know more about it. Global is the variable outside of your main function, right? It is defined in your file. So yeah, you could do that. And whenever you run it, it will give you a 0. So this is the global variable. That's slightly different from what's inside here. It's called local. But anyway, I will discuss that later when we talk about the global versus local versus static and many of the concept meanings. But as is for now, you just remember all the local variables you declared, they have some random values. Always remember to initialize them, right? That will be a good habit. So assignment, that's a little bit different from initialization, right? Because you don't have to put a type here. You just say variable name, assign some expression. And this is basically what compiler will do is they will find the location of your variable name in memory, right? They will copy whatever in your right, copy it to the exact location in your memory part. So assignment, we will first evaluate the right-hand side first. We will evaluate the right-hand side in your assignment first, then assign it to the variable on the left. You will see what we mean by this one later when we talk about more things. All right. So one thing that's you should understand is if you are new to programming, you should know the functions are running line by line. So anything that's already evaluated, if you change in later, that doesn't reflect in your previous instruction. What we mean is if we have A equals to 10, right? Int B assigned as 11. Then we say B assigned as A, then A assigned as 20. Right. So if we ask what is the value of B, it should be 10, right? That's what we mean is what you change in the later time will not reflect on your previous instructions. Because when you run to here, after you run this line, B will becomes 10, and A will becomes 10, right? And after running this line, B will still be 10, and A will becomes 20. Hey, wait, what's that? Let me open it. Right, so that's the, what do we mean by executing line by line? But in the future, when you know about reference, right? If someone reference to another variable, if a variable change in the future, the old value will also change. But that's a future story. No, they will not change the previous values, right? So that's that. All right, so first example would be very simple, right? We define a school name, then assign this school name to a new school name, and assign another school name. So these are very simple, right? First one, initialize the values, right? And the second one, we could initialize a variable with a variable name. We initialize a variable called a new school name with an old variable called a school name, right? We could do that. Another example would be a little bit complex, right? How about I equal j equal k equal 0, right? What is the order?
0 to k.
Yes. Yes, that's basically the step. Well, remember what we said? Whenever we assign, whenever we see an assignment, we will evaluate the right hand first, right? We will compute this one first, then assign the result to I. And when we see this one, because we see an assignment, we know we will evaluate the right-hand side first, then assign it to J, right? So we will do this one first. When we see this assign, we will evaluate the 0 first, then assign to K. When this one is done, assign the value of K to J, then assign the value of J to I, right? So this is a simple way to write a assignment that these three are exactly the same. But I would not recommend writing in this way, right? Never write your code in this way, because it is making your readers much harder to understand your code. Just write it in 3 lines, right? Even typing is longer, but that one is easier to read. So readability is more important than less lines of code. It doesn't matter you have longer code. All right, so another example is we include some of the implicit conversion in it. What do we mean by implicit conversion? Like we said, the type cannot change. So A is a floating point number. Then we assign a floating point number to an integer, right? There exists some of the conversions to it. You will see this kind of code. And people do conversion, right? If we are a math class, right? The B could be 1 or 2, right? If we run up, it becomes 2. If we run down, it becomes 1 when we convert from A to B. So in C++, we always remove the end of the integer part. We just B will only becomes 1, will not becomes 1 point, will not becomes 2. So let me show you the example. Right, floating point A, 1.9, B assigned to A. If we run it, you will see the output is 1, right? Even if it's 1.9999, let's see what's the output. It's still 1, right? It will remove everything in the other than the integer part. It's not run up, all right? So next line will be converting back. Converting back from integer to a double, right? When you see in math, right? A equals to this number, B equals to A, C equals to B. Right? It should be C equals to A, right? But indeed it's not. Yeah, it should be 1.0. It's only output 1, but it is indeed stored in floating point number. It is 1. It's exactly the same as 1.0. So remember we said execute line by line, right? First line, A equals 1.9999. Whenever you execute the second line, right? the B can only contains value 1. It will not keep the information, which means this 0.99999, they are already removed. So what you can see here is B can only be 1. It will never be, there will be no more information stored in the integer part. Integer can only store the integer part. So when you assign integer back to a floating point number or a double number, it cannot keep the original information because the original information is already gone. You will never get it back, right? But if you want to assign A to it, it can keep the original information. So that's basically the trick. Yeah, it's close to 2 because it's already close to 2. All right, so let me go to next one. We said characters are just integers, right? ASCII code. So it's just integers. It's very easy to assign a character to an integer. There's no information loss in it. A is 65, then D is 65. We could automatically output the number, right? If you assign B to capitalized A, if you want to output B, it will just the exact ASCII number for it, right? B becomes 65 because characters are just numbers, so you can easily store it in integers and you can print it like this one, right? All right, we will cover more about conversions later, but at least for now, you just remember characters and integers are exactly the same. They could assign character to integer or integer to character. They're all fine. So let's go to next part. A little bit complex, right? How to swap two values. Initially, I is 10, j equals to 20. Then we do I equal to j equal to I, right? We are expecting these two numbers to swap. So let's see. So what's the output of I and j? Yeah, good. So the output is 20 and 20. Right. As you can see, we are expecting the code I equal to j equal to I, so that they can swap. But indeed, it's got a 20 and a 20. So how can we debug? In your IDE, I'm showing it using my Xcode or Xcode in MacBook. In your Windows, it should be Visual Studio. You can break a point here. This is a break a point, right? A breakpoint. And then when you run it, you debug it, it will run your code and stop here. It will stop. And everything before it, it will be executed. Everything after it, it will not execute it. So as you can see, these fonts are too small. I don't know how to make it large, but it shows I equals to 10 and j equals to 20. All right, and there's a button so that you can run line by line. It's called a step over one instruction. So let me step one step. So after that, line 13 is executed and line 14 haven't started yet. And in your debug mode, you could check what's the value of I and j. As you can see, both I and j becomes 20. All right, because you assign j to I. J is 20, and now I becomes 20. J is also 20, and you can see it in your debug console. You could see the variable values, all right? And you can continue running, assign I back to j, because before line 14, both I and j are 20. So you assign I to j, both of them are also 20. So that's how you can use your debug console. So as you can see in here, you know, this line should be error in line 13, right? In line 13, there will be some problems because when you run in here, the old information of I is lost. When you assign I to j, I becomes 20 and the j becomes 20. Your information about the 10 is lost. You lost the information about 10. So after line 13, whatever you do, you will never get back your 10, right? So how can we do it? What can we do? what can we do? Because we lost the information 10, right? Then what can we do?
Right.
Yes, we can define another variable before the line I assigned to j, right? We can set a temporal variable and give the value I, so that this temporal variable will store the information 10. Because when we run in this line, we know that 10 is lost. So we have to keep 10 in some place, right? And then at the end of it, you are not assigning the new value of I to j, but you are assigning the old value of I to j. That's what we can swap two values. We need to introduce a third variable, right? Because the information is lost when we do assignment. No matter it's I assigned to j or j assigned to I, we will lost some information. We have to use a new variable to remember the lost information. And at the end, we revert it back to our old values, right? So when we run it, we could see these two values have successfully swapped, right? So this is how we do swapping. Any questions? Anyone knows how to do it in Python? In Python, it will be very easy, all right? Wait a minute. I comma j assigned as j comma I. This is Python's way to swap two values. So that will be quite easy. But in C++, we do this way. All right, introduce a third variable and store the lost information, then do the 2 assignments or 3 assignments. All right, so that's that. Next, we have talked about the characters, right? We talk about strings. Then we can do cin. We can ask the user to give us some user input. So that's very important because you write a program to interact between the users. Users want to use your program. So this is how to do input. There's a slightly different from cin and cout. As you can see, this is using the right hand. Yeah, you are stream. You think about stream into the first name, stream into the last name. Right, cout, you are stream into the cout. So you are using your keyboard, type in your first name, type in your last name. Cout, you are output 1, output 2. So their directions are slightly different. So as you can see, this is a cout, all right? And this is a cin, all right? Change this direction. Cin and cout, the only difference is the direction, right? Cin in this direction, cout in this direction. Cin, you are stream into the variable. Cout, you are putting the output of your variable to this cout, right? So these are the only difference. And when you run it, you will be able to see, right? Most likely nothing happens because it's waiting for your input, right? It's actually waiting for your input. Okay. So unless you write down something, it can execute the code. So it's actually waiting there. All right. So this is the way we can read the values for one or more variables from the console. We say the console, we mean the keyboard. All right. We type in the keyboard. And for strings, there's something weird, right? Sometimes you will see there's something weird here. Is first one using cin for string variables, then you will stop at the first empty space, right? If you want to type in the whole sentence and keep it in one string, you cannot use a cin. For instance, if I want to define a string that is called a sentence, right? Sometimes I'm expecting someone to type in their sentence, right? It is waiting for me to write down sentence. Today is September, blah, blah, right? It only get the first string today, because whenever it meets an empty space, it will stop. It will stop reading. Right. So when you do seeing sentence, it's indeed not reading the whole sentence. It's reading the first word. If you want the whole line, what you need is to use the std get line. This one, I will talk about that later when we go to the string class. We will have a specific class for strings, but at least you now know seeing cannot read the whole sentence. Later, we will learn how to use get line to read the whole line from the keyboard. All right. So here is an example, and this one, what I want to show is, because you are writing a program, right? Users, whenever users use, you should dump some information for them. I will say, okay, please enter your first name. Then I will do seeing. So I will do see out first, and then do seeing. Otherwise, your user will not know what you are expecting, right? Like this one. Whenever I click on it, it's waiting for me to type in something, but it didn't specify what they are expecting, right? Maybe they're expecting 1, 2, 3. You never know, right? So it's better to give the user some hint what you are expecting, right? You're expecting some name, just type it. If you are expecting some numbers, tell them to give you some numbers. So that's the benefit of using this layout. Give user some hint. Right, then you can see in the name, right? Put it into a string variable, and also you can define another string variable called month, and you can define some integer, and all of them can be printed in this way, this simple way. All right, just to put a variable name here, because I know some of you have experience in C coding, right? If it's in C coding, it will be much more complex. You have to specify the type of name, the type of month, the type of day, and using printf, and also in seeing, in the C way, it's called a scanf, and it will be more complex. If you don't know that, it's good. Learn everything from C++. All right, so that will be a way to do input and output. So IO, we will talk more when we go to the file stream. So this is called IO stream. In one of the class, we will talk about a string stream, file stream, and many streams. All right, so they will have many ways to input and output. So for example, in our OJ, we are not asking the TA to type in some input to test your code, right? We have some files called input file, have some file called output file. So your code will run based on the input file and check if your output matches the output file. So if there's any character that doesn't match, you will get some error. All right, so you have to be careful about that. All right, so some of the operations. So first one is arithmetic, basic ones, plus, minus, multiply, divide, right? Modular. So what is modular in Chinese? What is the operation? Yeah, 取. So it's relative to divider, right? So if it's, for example, if we have integer remainder, we typically call it a remainder, 9 percentage 4. So what is the remainder? 1, right? The remainder. Because 9 equals to 4 times 2 plus 1, right? This is the remainder, 取 in Chinese. So remainder is percentage, percent, right? 9% 4. This is the operation. And we have some operations. 9 divided by 4, right? What is that? Yeah, it's 2. So when you divide, you get the 2. When you do percentage, you get the 1, right? So that's the basic operations. You could do plus, minus, multiply, divide, and the remainder, right? These are the basic operations. And some of the complex ones, you can write in this way. If it's y equals y plus x, you could make it short. Y plus equal x. If it's x equals x minus 5, it could be x minus equal 5. So people typically write in this way because it's much shorter, right? Because we want to type as many characters as we like. So this one and this one, the last one is a little bit tricky, right? The last one, as you can see, price equals price times parentheses units plus 1. It could be written as price times equal units plus 1. So when we said, whenever we see an equal, we will evaluate the right-hand side first, right? We will evaluate the unit plus 1 first. That's why we don't need this parenthesis. We will evaluate the unit plus 1 first. Then we see this symbol. This symbol means price equals price times whatever in your right, right? So that's some of the shorthands. And we have a very common thing is like I equals I plus 1. You will see it frequently, especially in your for loop, in the loop index, right? When you want to do something to the first one, then do something to the second one, third one, that's called a for loop. And in your for loop, you will see something like the I equals I plus 1. And so we have some special shorthand. You will see many places using this kind of shorthand. So first 2 is I equals to I plus 1, right? You could write as I plus plus or plus plus I, they are the same. And you could also use the right hand 2 parts to represent I equals to I minus 1, right? So let's write it here. So assuming we have an integer I, right? If we want to say I equals I plus 1, then first we could write I equal plus a plus equal 1, right? That's 1. Let me give an initial number here, unless otherwise it's complaining, right? We could write plus plus I. We could write minus minus I. We could write I plus plus. Oh, by the way, it's not the same. Okay, all these are the same. All right, all these 4 lines, they represent the same thing. I plus equal 1 is exactly the same as this one. Plus plus I, the same one. I plus plus, the same one. All right, all these 4 lines represent the same thing. Similarly, if we want to minus, what we can do is I minus equal 1, minus minus I minus minus. Right. So at the first time, when you see this kind of representations, it will be very weird. So if I see out I, what is the output? Initially equal to 0. Yeah, minus 1, minus 2, minus 3, minus 4, right? -4. The answer is minus 4, right? Because you are deducting 4 times. Any questions? It's just a shorthand, right? They are exactly the same. But this shorthand could make some of the confusions. Let's see. First one, simple. I assign 10 to I, right? Next one, a little bit complex. J equals plus plus I. Let's copy this. Equals 10. J equals, what is I? What is J? 10 and 11?
11 and 11.
11 and 11, good. Yeah, so in here, it's basically 11 and 11. if you can see running here, 11 and 11. What if like this? What's the output? What's the output if I put j equals I plus plus? Which one is 11?
I
Yeah, 11 and 10, right? See the difference? That's the difference between plus plus and plus plus I and I plus plus. So let me explain it. So in this case, what we are doing is, because it's put it in the right-hand side, it is actually first return I, then do I equals I plus 1. All right, so first one, it will return I to j, then I will do I plus 1. But if, let me comment this out. But if it's plus plus I, what it will do is in the reverse order, right? Something like this. I will do increment I first, then return this I. So that's the difference between I plus plus and a plus plus I. So similar to the swapping case, right? In the lower level, in the machine code, we would say this one, how does it implement this I plus plus? People will use a temporary variable to remember the old I, using a temporary variable to remember the old I, then increment I, then return this temporary old value of I. So that's how it is implemented. And how about this one? This one just 2 steps, increment I and return I. So as you can see, I plus plus is one more step than plus plus I, because it requires some temporary variable to remember the old I. All right. So here is what I said. Always use the prefix one, right? Put plus plus before your variables, unless you need the old value. If you don't need the old value, you just use plus plus I instead of I plus plus, because it will save you some time. But I believe nowadays people don't care about that. So because our machines are fast enough. So don't worry about this note. It's just for someone who requires extreme performance, right? Otherwise, you can ignore that one. So whether you write this or write this, it doesn't matter. But sometimes some of the people would like doing something like this, and plus, right? You could say plus 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 I plus plus, right? I believe this is also valid. Is this valid? It's not valid. Plus plus I plus 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 I. Oh, wait, one more. All right. I believe this one is valid, right? Can we still run it? Build failed. Okay, you cannot do that. But this one you could do that. Yeah. Some of the weird notations when you see these ones, right? I will not ask you this kind of questions in your exam, but you have to know, because of this plus plus, it will introduce many of the confusions if you don't write your code correctly. So this kind of symbols, because most likely it's doing these things. For example, it will evaluate plus plus I first, so it will becomes a different answer. Yeah, it really depends on which order you evaluate, right? If you evaluate this one as I plus 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 I, or I plus 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 I, right? Let me write it. So you could write it in this way, right? It will be a different. Yeah, basically it's writing this way. Or you could write it in this way, right? But as I said, don't write your code in this way, all right? Don't write your code like this. Other people will not be able to understand you, all right? These are valid, but don't write it in this way. It's just confusing people. Okay, so here are some of the arithmetic exercise. It's basically compute the total values of all coins, assuming we have 3 type of coins, not assuming this exists in US. So pennies, $0.01, dime, $0.1, quarter, $0.25. These are example from the book, a big C++. All right. So if you have the book, you will see exact exercise, and you will see their output, their code, something like this. Right. So this is just to summarize what we have learned from characters or strings or C in or C out, and also how to do the computations. Right. Many of the code is look like this. Everything are written in very simple ways. And like we said, we first give the user some input, some hint, right? Please input something, right? Input number of pennies, dimes, and quarters. What do we tell us? What we are tell them is, okay, first your input should be some numbers, right? Give us the number of coins, number of pennies. Then these 3 numbers should be in order. First one is pennies, then it's dimes, then it's quarters, right? You are giving the user this kind of information. Please give me this kind of inputs. So then you can input them in order, right? Give the pennies, give the dimes, give the quarters. So that's basically what you should write in your own project. But remember, in OJ system, right? In OJ system, this kind of OJ system, when we say this is our input, this is our output, we will compare your output with our output, right? If you in here you say, okay, please input your sample input, right? Then you will get wrong, because in our output we don't have this kind of hint. We don't have this kind of hint. We will compare exactly your output with our output. Everything you see out will be shown in here. So if we don't give hint here, you should never include any hint here. All right? Does it make sense? Because we do exact comparison. For example, if this is Apple, right? If my code is, okay, C out Apple, right? For that example, if I have this code, you output Apple, okay, you get 100%, right? Great for this homework. Otherwise, if you say, please input your string before converting to lowercase. In that case, we will compare your output with our output. Your output is this long string. Our output is just Apple. So you will get 0 for this output, all right? So for OJ system, if we don't ask you to give any hint, don't do that, because we are doing exact comparison between your output and our output. But for your own project, what you should do is remember to include this kind of hint. Otherwise, people will never be able to know what you are trying to input, right? Let me show you. I believe I already showed you, but anyway, let's try it again, right? If we have this line, then we have this line, right? In your daily project, if you don't have any hint, I'm just waiting. No one knows what's happening. Is my machine still running? Am I done? Right? You never know. Because in the future, when your program becomes larger, it may take longer time to finish. So you are thinking, okay, the program might still running. But indeed, it's expecting you to give some input. Unless you give some input, it will continue running. But otherwise, it will just stop there, waiting for your input. All right? So this is the type, this way are for the OJ system, right? You don't print any hints, but this style is for your daily project, right? If in the future you have a large project to run, you should do this way. And then we compute, right, the total dollars, right? It's very simple to write. We said we could do arithmetic, multiply plus multiply plus multiply, right? And in maybe next lecture, we will cover who will compute first, right? Will it do penny times 0.01 plus dime? The output then times 0.01, then the output plus quarters, and the output times 0.25, right? So sometimes we will have these kind of confusions. Let's say total dollars equals to this plus quarter times this. So next class, we will talk about which operation we'll do first, right? We sometimes might think, okay, is it doing this, right? We will evaluate penny times 0.1 first plus dime, right? It might be some confusions. And then after doing this, we will do this multiply. After doing this multiply, we will do this adding, then multiply 25, right? This is about the order of arithmetic. So in the order of arithmetic, at least for now, we just, for adding and multiply, we just follow the common sense, right? Multiply we'll do first, then we will do adding. So similar here, we could easily write it in this way, because in C++, there are some inherent orders. It will do, what it will do is they will do multiply first, then multiply first, then multiply first, then do adding. You don't need this parenthesis, all right? So that's the order that C++ will enforce. So don't worry about that. We will talk about that later. All right, so this is the how to compute arithmetic. And as you can see, we could easily do is integer times a floating point number, right? That's what we can do. Integer times floating point number, integer times floating point numbers. And we can adding them up and assign it to a variable. That variable is this is the initialization of a variable total dollars. Right? We will evaluate the right-hand side first, and assign it to total dollars. And as you can see, we define this one as a double. You could also use a float because it's a very small number. You don't have to use double. So that's this arithmetic. And in the future, we will learn how to get rid of this kind of numbers. All right. But anyway, for now, just leave it here. And we could see out. Right? See out is pretty simple. Just give some hint. Give some hint. Total value equals. Then get the number. Then adding a new line here, right? And the return. This is the simplest program we could write. All right. Any questions on it? Easy to follow. All right. So about input, one more thing I want to talk about is the format, because we are expecting the user to give us something, right? But users will not listen to us. You are developers. You put a program online, right? But users are someone you never know about it. So you ask them to input 3 numbers. Will they listen to you? Might be, might not, right? They are trying to crash your machine sometimes. So let's see. There are a few ways to input 3 numbers. First way is quite simple. 1 space, as many space as you want, 2 space, right? You can do like that. Let me output the total dollars. Right, so you could use a space. Anything that looks like a space, it could also work. What's the space like? Right, you could put space, tab, yeah, good. And 2, right? And then new line, right? New line. You can put an enter, right? Anything looks like a space, it will work. You could put as many empty space as you like, right? It will work. Let me output these 3 numbers so that you can see exactly what is my input. And I need to change the direction. So 1, tab 2, enter, tab 3, right? You could output 1, 2, 3. By the way, you should put some empty space in the middle so that these numbers are not connected to each other. 1 empty, 2 tab, 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 new line, tab, tab, 3, right? 1, 2, 3. So anything that looks like an empty space, it will work. And how about this? Right? Sometimes people like to input numbers like this: 1, comma 2, comma 3. Right? So let's try it. How about 1, comma 2, comma 3? It's actually getting 1, 0, 1. Right? It's very weird. It's because when you are inputting this kind of symbols to it, indeed, let me try 1, comma 2. It can also stop. By the way, if you only input one number, it's always waiting, right? If I type in 1, it's waiting. If I type 2, still waiting. Unless it's getting all the numbers it needs, it will stop. So let me try. If I input is 1, comma 2, will it stop? Or it's still waiting? It stopped, right? And it means 1, comma 2 is enough. They think they will represent the comma, right, as kind of integer, but it's weird why it's getting 0, right? It's way too complex. I will not explain it, but anyway, what I mean is you cannot count on users to give you the correct format. So let me see if this one can work. Yeah, this one can work. This comma is represented as both 0 and 1, right? It's very weird. Anyway, you don't have to know exactly what the output should be, but just remember, this kind of characters or strings will give you the incorrect numbers. All right, let me give you the floating point number. What is the floating point number? 10.75. 10.75, right? Again, it's getting some weird number. Indeed, well, if you want to try, you could say, how about 10 point, right? It's also give you the exact same number. Yeah, 0 and 1. So anyway, so the key point is for our OJ or project assignment, you can count on us because we are friendly, we are good people. We will give you the correct format, right? But if you in the future you go to the job market, you create your applications for other people to run, never count on the user to give you the correct input. That's a lot of the machines done because of the user's input. People will try to hack into it. So if you guys heard about some of the code injection, they are trying to write a code in your input, then so that your server will run their code and some of the informations will leak. So do not count on the users. So what we can do is we will learn that in the future. What we can do is using getLine to read the whole line, even if they give you the numbers. Using getLine to read the whole line, then apply some of the functions to check if their input are valid. If their input are invalid, then just kill the program. Never run it, otherwise your program might fail. So this will be a very good habit to use getLine, but we will discuss later. At least for our project, for now and for OJ, anything you can rely on us. We'll give you the correct input. Right? You could use these ones. If we say we will give you numbers, we will always give you numbers. Right? We will not test your program based on some invalid input. You can count on us. Let me see. Let's stop here and let's show you the OJ system. Right. Last lecture, last lab, we should have a contest. Right. And this contest is already due. It's due. I don't know what's the due date they set, but I asked them to set as Sunday night, right? Sunday night, and this is the every lab every week you will have one contest. Click on the contest, click on the problems, right? They will have the problems, and then click on it, and then you can start writing the code and submit the code. All right. For the first project, we might not grade you because first week is for you to get familiar with these systems. But starting from this week, we will start grading. And as you can see, 157 accepted, 369 get wrong answer. All right. I believe 4 parallel sections should be 180 students, right? So it means still there are some students didn't pass this one, right? So remember, every week we will create one new contest here, all right? But for the problems, majority of the problems are too hard for you guys for now, at least for now. Maybe after 2 or 3 weeks, you will be able to solve some of them. And yeah, one student asked me about this red bird symbols, all right? It asks you to print this one. It's just a copy paste this one. And you can print it either line by line or the whole string. But remember, when they print it, they forgot there are actually some empty space after it. We are comparing it with the empty space. Why? We say it. Please check and make sure your output size is 26 by 30, including the empty space. So if you don't have the empty space, you might fail. So as I can see already, some submissions, 300 failed and 57 success. All right. What you can do is, I'm not sure if I'm allowed to copy here. No, there's no copy in the output. Anyway, so remember that. So we will have the specific requirement here. If we didn't say that, we will not compare your empty space. But if we say that, we will compare your empty space, correct? If we don't say anything, we will ignore your empty space as long as your output is correct. But for this one, you have to follow the rules. It is set in here. So any questions?
So if I fail at first, will it be influenced to my grade?
No, we will only check your last one. It will not influence your grade. You could submit as many times as you want. Yeah, so it's for your exercise, actually, lab exercise. But it will be counted in here, right? I can see how many of them failed. So if someone submitted multiple times, it will also shown in here. This is the ratio I can see. So it's very good for me to get the statistics, right? Which part are some people get much easier, or some part are harder. So this one, I believe it's still too hard, but some people already submitted. So for this one, you need maybe a for loop to iterate from one character to another character. You don't have to do it now, but after we do for loop, you will be able to do it. So most of them are too hard for you. All right. Any more questions?